Hello guys, welcome back to my YouTube channel. Today I am going to solve day 20 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I am going to solve problem number 1863, sum of all subset XOR totals. Okay, so this question is very important, and during telephonic interviews, okay, so many times companies ask such type of questions. Okay, so now let's read the problem statement first. So in this problem we have given one nums array. Okay, so for this particular nums array we have to find all the subsets. Okay, and after finding the subsets we have to do the XOR of all the subsets, and in the end result we have to just give the summation. Okay, so this is problem statement. So the XOR total of an array is defined as the bitwise XOR of all its element, or 0 if the array is empty. Okay, so for example, the XOR total of the array 256 is 2 XOR 5 XOR 6 is equal to 1. Okay, this is the XOR total of the array. So we have given an array nums, right? And we have to return the sum of all the XOR totals for every subset of nums. Okay, so we have to calculate all the subsets of this num. Okay, so note, subsets with the same elements should be counted multiple times. Okay, an array A is a subset of an array B if A can be obtained from B by deleting some or possibly 0 elements of B. Okay, so let's understand this problem. Okay, with one example here. So let me copy this example number 2. Okay, 516. So first what I'm going to show you here, the approach one that I'm going to use to solve this problem. But before that, let's create the subsets. Okay, so how I'm going to create the subsets of this 516. Okay, so this is my array, right? 5, 1 and 6. Okay, initially let's say my I index is at this position. Okay, my I index is at this position. Okay, so if I want to include this 5 in my subset, then how I'm going to write it? Okay, so this is 5, 1, 6. Okay, if I include 1 in my subset, then it is going to look like this, and definitely my I is going to move forward. Okay, but if I don't include this I index, okay, this 5, okay, this 5, okay, here I have to write 5. Okay, if I don't include this 5, then how my subset is going to look like? So my subset will be empty, right? There is nothing, and definitely my I is going to move forward. 5, 1, 6, and now my I reaches at this position. Okay, so here and here I am excluding I, and here I am including the I in my subset. Okay, including I in my subset. Okay, this is my first step. Okay, then next time if I include this I element in my subset, then how my subset is going to look like? It is going to look like this: 5 and 1. Okay, and definitely my I is going to move one step forward. Okay, so now my I reaches at this position. If I don't include this I, okay, so here I am writing I for including and E for excluding. If I don't add this element at index I in my subset, then how my subset is going to look like? Just 5 is there. Okay, and nothing. So definitely my I is going to move one step forward. Okay, so now my I reaches at this position. Okay, this is done. Then same way here, if I include I, okay, if I include I, then how my subset is going to look like? Just 1 is there, right? And definitely my I is going to move one step forward. Okay, so now my I reaches at this position. Okay, if I exclude this if I exclude the element at this particular index I, then how my subset is going to look like? It is just empty. Okay, nothing is there, and definitely my I is going to move one step forward. 5, 1, 6, and my I reaches at this position. Okay, then same way here also, if I include this I or if I exclude this I. Okay, so if I include this I, then my subset is going to look like 5, 1 and 6. Okay, this is how my subset is going to look like, and I is going to reach out of index bound, right? Okay, so from here I don't need to execute, my I reaches out of the bound, right? So this is one of my subset. Okay, this is one subset because my I reaches out of bound, so I have to return this subset. Okay, this is one of my subset. Okay, this is done. Then after that, if I exclude this element at this particular index, then my subset is going to look like this 5 1 only. Okay, okay, and my I here also it reaches out of index, right? It reaches out of index at this position. Okay, so this is also one of my subset. Okay, same way I am writing here, if I include, exclude, include, exclude, include, exclude. Okay, I include, exclude, include, exclude, include, and exclude. Okay, so here if I include the element at this particular index in my subset, then my subset is going to look like this 5 and 6, and definitely my I reaches out of bound. Okay, so I'm not going to write the same thing again and again. Okay, and if I exclude this, then my subset is going to look like this. If I include the element at index I, then my subset is going to look like this 1 6. Okay, and here if I exclude, then it is going to look like just 1. Okay, if I include this, then my subset is going to look like this 6. Okay, this is 6, and if I exclude this, then it is going to look like just empty subset. Okay, now let me do one thing here. Okay, so now it is clear, right? So one time I am including and one time I am excluding, right? So this is done. Now see, okay, this is done. Now see, we have found all the subsets. Okay, so let's count. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, and this is 8, one empty subset. Okay, so total 8 subsets are there, right? So see here, how many subsets are there in this problem statement? Total 5 na, right? Total 8 na, 8 subsets that we have calculated. Okay, so one is 5, one is 1, one is 6, right? So see here, 5 1 6, and one empty subset is also there, right? One empty subset. Okay, so here this is empty subset. Okay, one is empty subset, one is 5, one is 1, one is 6, then we have 5 1 5 6, right? 5 1 5 6 is also there, and 1 6 is also there, right? 1 6 is also there, and one subset is 5 1 6, so 5 1 6 is also there, right? So we have calculated all the subsets. Okay, so I hope that this is clear how we are finding the subsets. Okay, so this is also one important part. Okay, so many times you will face this question in interviews. Okay, interviews or do competitive programming. Okay, find the subsets, find all the subsets of this particular array, of this particular nums array. Okay, so many times you will find such questions during competitive programming. Okay, so I hope that this is clear how we are creating the subsets. Okay, how we are creating the subsets. Okay, so here I am talking about the approach one. Okay, there is a simple approach as well. Okay, but this is the first approach that everyone should know how to create the subsets. Okay, so after creating the subsets, what I am going to do here, I am going to calculate the XOR of all the numbers. XOR of 5 1 6. What is the XOR of 5 1? What is the XOR of 5 6? What is the XOR of this 5? What is the XOR of 1 6? What is the XOR of 1? What is the XOR of 6? And what is the XOR of this empty? Okay, so 5 1 6 XOR. So how we are calculating the XOR value? Okay, so simple. Okay, let me write this 5 in binary form. So in binary form I am going to write it like this: 0. Okay, here let's say 1 2 4 8. Okay, so I'm writing 5, so I'm going to write 5 like this: 0 1 0 1. Okay, this is how I'm going to write 5, and I'm going to write 1 as 0 0 0 1, and I'm going to write 6 as 0 1 1 0. Okay, now let's do the XOR. Okay, let's do the XOR. So what is the XOR? Okay, so here 1 1 XOR of same element is 0 and 0 0 0. Okay, 0 0 0 and 0 1 1 1 1 0 0 is going to give 0. Okay, this is also going to give 0. Okay, so I hope that you guys are already aware what is the XOR operation. Okay, so if two elements are 1 and 1, then the XOR result is 0. If two elements are 0 0, then also XOR result is 0. Okay, if the XOR one element is 1 and one other element is 0, then we have to return just 1. If one element is 0 and other one is 1, then we have to return 1. Okay, let's say this is A, this is B, and this is XOR result. Okay, this is a simple formula. So here, what is the output of XOR of 5 and 6? It's nothing but 2. Okay, so let's see in the example what is the output. 5 and 6. So see, 5 and 6 has an XOR total of 5 XOR 1 XOR 6 is equal to 2, and this is what we are getting, right? So we have to calculate the XOR of all these. Okay, all these subsets, and then we have to return the result. Okay, this is our approach 1. Okay, so now I'm going to write the same code that I've explained, how I'm creating the subsets, and after that how I'm going to iterate over each subset one by one and finding the XOR, and in the end I'm going to add the XOR sum of all these. Okay, this is what I'm going to write here. Okay, in my code. Okay, so now let's write the code. Okay, so here first create one list of integers. Okay, so this is going to store nothing but my all subsets. Okay, so all subsets I'm going to store in this all subsets. Okay, this is my new array list. Okay, then after that let's create. Okay, in the list of integers, we are just going to store one list of integer, right? And that list of integer is going to store my current subset values. Okay, so here I'm going to write current subset is equal to new array list. Okay, so I'm going to write the very simple code. Okay, whatever I have explained here now, first I'm going to create the subsets. Okay, so for creating a subset, okay, this is also important, how to create a subset. Okay, so just listen carefully how I'm going to write the code for this same approach. Okay, so here I have created one list of integers for all subsets, and I have created one list of integer for current subset. Okay, now from here I am going to call one method, okay, helper method, which is going to help me generating the subset. So here generate subset. Okay, and in this I'm going to pass my nums array. Okay, and then after that I'm going to pass my initial index. I'm going to start from 0, and then after that I'm going to pass my current subset, and then after that I am going to pass all subset. Okay, so this helper method is going to generate all the subsets for me. Okay, so now let's define this generate subset method. Okay, so write private void. I hope, okay, let me zoom it. Private void generate subsets, and in this pass our nums array. Okay, then pass my index, then pass my current subset. Okay, just copy paste, and then after that pass list of integers of all subsets. Okay, this is done. Let me copy it again. Okay, this is done. Now after this, inside this, okay, so here when I am returning when my eye is reaching out of bound. Okay, see here in the last step, whenever my eye is reaching out of bound, okay, at this end position, no, right, this is my nums array. What is the size? Size is 3, right? size is 3, and this is 0th index, this is first index, this is second index. So whenever my I reaches at this 3 index, okay, so every time I'm returning from there, right? So what I'm going to write here, if I is equal to nums dot length, definitely is going to reach out of bound. Okay, in that case I am going to add, okay, this is all subsets, okay, list of integers, all subsets. In this all subsets I am going to add my current subset. Okay, so new array list, and I'm just going to pass my current subset. Okay, so in my all subsets I am passing my current subset. Okay, this is what I'm going to do here, and from here just return. Okay, then every time, okay, while generating the subsets, first time I'm including, and after that I am also checking for the excluding 2 times. Okay, every time I'm checking for 2 cases. First is whether I'm going to include the current index or I'm going to exclude the current index. This is what I'm doing, right? So if I include the current index, so I'm going to write here current in my current subset. If I want to add in my current subset, if I want to add my current element, okay, include, this is include process, right? If I include this nums of I, then again I am going to call this helper method. Let me copy this here. One time I'm including nums, this I will become I plus 1 after including, and same thing I'm passing. If I want to exclude, then what I'm going to do, I'm going to write current subset dot remove, and here what is the current size. Okay, this is my subset now. I have already removed one time. Now I don't want to remove this. Okay, so I have to remove the last inserted element. Okay, so here what I'm going to do, current subset dot size, whatever the size of my list, and from this I am subtracting 1. Okay, this is done, and then again I have to call this recursive method generate subsets, and in now nums I plus 1. Okay, same thing. Okay, same thing that we have to pass. Okay, this is done. This is so simple, right? We have generated the subsets. Okay, this generate subsets is going to generate the subsets. Okay, now after generating the subsets, okay, we have generated all these subsets. Okay, with this piece of code. Okay, now we have to calculate the total XOR of all these values. Okay, so here what I'm going to do here, after this I'm going to create one variable int total XOR sum, and going to pass value as 0. Okay, now I am going to iterate. Okay, these are all lists, right? This is one list, this is one list, this is one list, and all lists are there in one all subsets list. Okay, all these lists are in one subset, all subsets list. Okay, so I am going to iterate all the list one by one. Okay, so what is my list containing? List is containing integers, right? List integer, and one by one. Okay, first I am going to check for this subset, then I'm going to check for this subset, then I'm going to check for this subset. Okay, one by one I have to iterate over all these subsets. So where is my all subsets? This is my all subsets. Let me copy it. So I am iterating. 1 second. I am going to iterate one by one over all subsets. Okay, this is done. Then after that, for current subset, okay, for this particular subset I have to calculate the XOR. Okay, so here I am going to create one variable int subset XOR. Okay, for this particular subset, what is my XOR sum? Subset XOR is equal to 0 initially, and then I have to iterate over all the elements in this 516. Okay, so for int num of over all the elements. Okay, all the elements of this subset. Okay, I'm going to iterate, right? And in subset XOR 1 second, subset XOR is equal to subset XOR plus this num. Okay, subset XOR is equal to subset XOR with num. Okay, this is done. Then also, okay, I am finding the subset XOR of all these. Okay, then after that I have to add everything in my total XOR, total XOR sum. So here my total XOR sum will become copy paste, 1 second, total XOR sum is equal to total XOR sum plus is equal to subset XOR. Okay, and in the end I have to just return the total XOR sum. Okay, that's it. Return total XOR sum. 1 second. Okay, this is done. Now let's run the code and see if there are any code issues. Yes, there are some issues with the code. All subsets. Okay, I think all subsets should be there. All subsets. And any other mistake? Line number 10, line number 8. Okay, let's run it. We have defined all subsets as well. Okay, all subsets. Here also I am writing subsets. Some spelling mistake. Let's run it again. So see, all the test cases has been accepted, right? Now let's submit the code and see the runtime. Okay, so see, our solution is accepted, right? But runtime is just 15 milliseconds. Okay, it is taking a lot of time, right? This is our code. Okay, so now see what is happening here. Okay, so now I'm going to explain the time complexity and the space complexity for this one. Okay, so first let's talk about the time complexity. Okay, so you guys know that we are creating first subsets. Okay, so this generate subsets method, okay, this method generates all the possible subsets of the given array nums, right, for an array length of n, right. There are 2 raised to power n subsets, right? So what is the length of this nums array? 3, right? 2 raised to power 3 is nothing but 8. Okay, we are generating 8 subsets in total, right? And each subset generation involves a recursive call, right, that either includes the current element or excludes the current element. Okay, so this is how we are generating 2 raised to power n subsets, right? So the total time complexity is going to be, for subset generation, total time complexity is going to be O of 2 raised to power n. This is just for subset generation. After that, we are also doing the XOR calculation. After generating all the subsets, the code iterates through each subset to calculate the XOR of its elements. Okay, we are iterating over all the elements, right, through each subset, okay, to calculate the XOR of all the elements. So there are total 2 raised to power n subsets, right, and each subset can have up to n elements. Okay, it can have up to n elements. Therefore, calculating the XOR for all subsets in the worst case is going to take O raised to power n into 2 power n time complexity. Okay, so what is my overall time complexity? Okay, overall time complexity is equal to O of 2n plus O of n into 2n is nothing but O of n 2n. Okay, n 2n. So this is going to be my overall time complexity for approach 1. Okay, so for approach 1, my time complexity is O of n into 2n overall. Okay, 2n for generating all the subsets, right, and this n we are doing the XOR as well, right? So I hope that this is clear. Okay, so this 2n is for subset generation and this n into 2n for XOR calculation, right? So this is my total time complexity. Okay, and what is my space complexity? So first thing is that we need the space for the subsets generation. Okay, the space required to store all the elements, all the subsets is equal to O of 2n into n, since there are 2 raised to power n subsets and each subset can have up to n elements. Okay, so space complexity is going to be O of n into 2n, and for recursion also we need some space. Okay, so the recursion stack for generating the subsets can go as deep as n level. Okay, leading to the additional space complexity of O of n. So overall I am just going to say that overall space complexity is also going to be same. Okay, why? One is for space for subset and one is for space for recursion. Okay, and space for subset is also going to be O of n to 2n and space for recursion is equal to O of n. So overall if I am combining, then I am going to say that my time complexity and space complexity, both are going to be of n into 2n. Okay, this is my approach 1. This is my approach 1. Okay, approach 2 is going to be very simple. Approach 2 is going to be very simple. In approach 2, I think there are hardly 5 to 6 lines. Okay, I'm not going to write much code for approach 2. Okay, so what is happening here in approach 1? Okay, in approach 1, I am generating the subsets and I'm storing the subsets, and after that I'm iterating over all the subsets one by one and finding the XOR and then give the summation result. But in approach 2, I'm not going to create the subsets. I'm not going to generate the subsets. Okay, I'm not going to generate the subsets. Okay, I'm not going to generate the subsets. I'm not going to generate all these subsets. But I'm going to do here, I'm going to calculate the XOR side by side. Okay, instead of creating the subset, I'm going to calculate the XOR. Okay, so what I'm going to do here, 516. Okay, initially my index is at this index. Okay, if I include this if I include this element, then my XOR element, then my XOR result is going to be look like this. Okay, if I include this 5 XOR, okay, if I include this, okay, then 5 XOR 0. Okay, if I don't include this, then it is going to be nothing. Okay, nothing. XOR value is 0. XOR value is equal to 0. Here XOR value is 5 XOR 0. So what is the result of 5 XOR 0? 1. Let me write it in binary form. 1 0 1 and 0. So result is going to be 5 only, right? Result is going to be 5 only. Okay, so 5 here XOR result is 5. XOR result is 5 and here XOR result is 0. Okay, then after that, if I include this 1, then my XOR result is 5 XOR 1. If I don't include this one, then my XOR result is nothing but 5 only. If I include this I, then my XOR result is 1. If I don't include this I, then my XOR result is 0, still 0. Okay, if I include, then 1. If I don't include, then 0. So what is 5 XOR 1? What is 5 XOR 1? 5 XOR 1. Okay, so 5 XOR 1 is nothing but 4, right? 5 XOR 1 is nothing but 4, right? So 5 XOR 1 is nothing but 4. Okay, then after that, it is at this index 6. Okay, so if I include this 6, then what is the XOR result that I'm going to get? What is the XOR of 5 1 and 6? Tell me, what is the XOR of 5 1 6? So 5 1 6 XOR is nothing but 2. Okay, we already know. So here my XOR value become 2, and if I don't include this, then what is the result? Then result is nothing but 4 only. Okay, 5 1. Okay, if I don't include 6. So here see, this is 2, this is 4. Okay, if I include 6, okay, if I include this 6, okay, if I include this 6, then what is my result? Okay, so here 5 and 6. Okay, what is the XOR of 5 and 6? 5 and 6 XOR is 3. Okay, if I don't include, then my result remain 5 only. Okay, 5 is the subset na, 5 is the last time XOR value is 5 na, right? And here in this last time XOR value is 1. Okay, if I include 6 in this 1, then what is my result? My result is 7. Okay, so here I am writing 7. If I don't include 6, then result is nothing but 1. Okay, same way here, if I add just 6, okay, last time my result was 0, and if I add 6, then my result is 6. If I don't add anything, then result is 0. Okay, so here I am just step by step, instead of generating the subsets, I am directly calculating the XOR values, if I include or if I exclude. Okay, this is what I am doing in approach 2, right? So now tell me here one thing. Okay, so this value is 2 and this value is 4. Okay, if I do the summation of these two and return the result here one level top, okay, I am going to return the result to the top one level up. So what is the result of this 2 plus 4? It is nothing but 6, right? 2 plus 4 is 6. If I return the result of this 3 and 5, what is that? My result? My result is 8. Okay, if I return the result of 7 and 1, okay, what is my result? My result is 8. If I return the result of 6 and 0, what is my returning result? A6. Okay, now again one level up. Okay, 6 and 8. What is the result of 6 and 8? 6 and 8 result is 14. Okay, 6 and 8 result is 14. What is the result of this 8 and 6? It is also 14. Right, now in the final level, okay, I am going to reach in the top. Okay, in 516. Okay, here I am returning. What is the result of 14 plus 14? 28. Okay, so see, 28 is our output. Right, this is nothing but my approach 2. Right, approach 2 is very simple. Right, very simple, easy and very simple. Right, so see how I am returning. So now this is my code. Okay, now you see I'm not going to do much. I'm just going to remove few lines. Okay, so first thing here, see, I'm not generating the subset. I'm not generating my current subset. I'm not generating my all subsets. Okay, so I'm just going to remove it. Okay, I don't need to do here anything. Okay, I don't need to do here anything. I'm just going to return this, return generate subsets num0, and here I am going to pass the current XOR value. Okay, initially the XOR value is 0 na. In the starting my XOR value is 0. Then I do, when I include 5, then I do the 5 XOR 0. Okay, if I don't include anything, then my XOR remains 0. Okay, so initially my XOR value is 0. Okay, so here I am passing 0. Okay, this is done. Then in this method, okay, I don't need to do anything here. I'm just going to write, I'm just going to delete it. Okay, now you will see how my this code is going to reduce to just few lines. Okay, here XOR, if my I becomes nums.length. Okay, so from here, okay, in the end we are just returning the XOR value now. If my I reaches out of bound, okay, so from here I return 2, and from this side I return 4, and just do the summation. Okay, this is what I'm doing. So here what I'm going to do, I'm just going to return XOR. Okay, I'm going to remove this line. I don't need to do this. Okay, this is done. Then after that, every time I am either including the current element or not including it. Okay, so here what I'm going to do, I'm not doing this. Right, if I am including this, okay, if I am including the current element, then here my XOR value will become nums of I current element and XOR. Okay, this is what my XOR value will become. If I am excluding the current element, then my value will become generate subset num I plus 1. Here I have to just write XOR. Okay, I don't need to do anything. Okay, so here see, if I'm including, then I did 5 XOR 0. If I'm not including, I'm just returning same XOR. Right, this is what I'm doing. So you need to include and exclude. I hope that this line is clear. And in the end we have to just return the sum of include and exclude. Okay, return include plus exclude. So see here, we are returning the sum every time. First 2, 4, 6, and from here 3, 5, 8, and then 6, 8 we have returned 14, and 14 then we have returned to the root. Okay, this is how we are returning step by step. And here let's change the method to int. Okay, int. Now let's run the code and see if there are any code issues. So see, all the test cases has been accepted. Now see the runtime for this specific code. Okay. Yes, so see, our solution is accepted. Right, all the test cases has been accepted, and the runtime is just 0 milliseconds. Okay, and see, code is very simple, just 16 lines hardly. Okay, if I remove the space, okay, for these extra lines, then you see, I think within just 13 lines. Okay, hardly 13 lines. Okay, so simple code. Okay, so this time we are not generating the subsets. Okay, we are directly calculating the XOR values. Okay, we are directly finding the XOR value and do the summation. Okay, we are not generating, so definitely this step is going to remove. Okay, so I am doing the XOR, okay, either including or excluding every time, so it is going to take this complexity of 2 power n. Okay, and other than this I am not iterating over the subsets again and again and then doing the XOR. Okay, so this is going to be my time complexity, just 2 raised to power n. Okay, So now my space complexity, what is my space complexity? Okay, so my space complexity is going to be of n. Okay, since we are going this much deeper, right, for this n number of elements. Now let's move to the approach number 3. Approach number 3. Okay, so approach number 3 is little bit tricky. Okay, but just a few lines of code for this one as well, but there is one pattern that we have to find out. Okay, so first nums array is 1 and 3. Okay, if I write 1 in binary form, then I'm going to write it like this, 0 0 1. And if I'm going to write 3 in a binary form, I am going to write it like this, 0 1 1. Okay, and output is 6. Okay, so output is 6. Okay, so I'm going to write output as this way, 1 1 0. Okay, in binary form. Okay, and for this 5 5 5 1 6, if I'm going to write 5 in binary form, then I am going to write it like this, 1 0 1 0. Okay, if I'm going to write 1 in binary form, I'm going to write it like this, 0 0 0 1. Okay, and if I'm going to write 6 in binary form, then I'm going to write it like this, 0 1 1 0. Okay, this is how I'm going to write 6, right? So now see here, if I do the OR operation for all these values 1 and 3, then what is the result that I'm getting? I'm getting this result, 1 1, right? This is the result that I'm getting, 1 1 0. Okay, let's ignore this 0. Okay, I'm getting this result. Okay, and if I'm doing the XOR of all these elements, then what is the result that I'm getting? I am getting this result. Result value is 28. Okay, so now for 28, how I'm going to write? So if I'm going to write 28 in binary form, then I'm going to write it like this, 1 1 1 0 0, right? So let me check, 1 2 4 8 16 16 8 24 28, right? So 28 is our output. Okay, so this is how we are going to write 28 in the binary form. Okay, so see here, let's ignore this value. Okay, this 0, let's ignore it. Okay, not required, right? So this is the result that I am getting when I am doing the bitwise OR of 1 and 3, 1 1. And this is the result that I am getting when I am doing the bitwise OR of 5 1 and 6. Okay, so what I am going to do here in this pattern, what is the value of n? N value is 2 in this case. What is the value of n here? N value is 3 in this case. Okay, so every time in my result that I am getting using bitwise OR, I am going to add n minus 1 number of zeros in the end. N minus 1 number of zeros in the end. Okay, n is 2, so here I am adding just 1 0. N is equal to 3, so here I am adding n minus 1 number of zeros, that is 2 zeros. Okay, 2 zeros. And now see, this 1 1 0 is same as my output. This 1 1 1 0 0 is same as my output, 1 1 1 0 0. Okay, this is one pattern that we have to notice. Okay, so actually it is very hard to recognize this pattern, but see, if you take any other example, you will find the same thing. Okay, this is the pattern that is coming every time. Okay, so we have to just do the bitwise OR, and then in the end we have to append n minus 1 number of zeros, and this is how we are getting the result. Okay, so now let's write the code for approach 3. Okay, so now let's remove everything. Okay, and now here, okay, so actually this approach is just going to take, I think, of n space complex, of n time complexity. Okay, so here int n is equal to nums dot length, and then int result is equal to 0, and then we have to iterate over all the elements. So for that I am going to use for each loop int num over nums array. I'm just going to do the OR of all number, bitwise OR. Okay, result is equal to bitwise OR of result with my num. Okay, I'm doing the bitwise OR, and then I'm just going to append the n minus one number of zeros in the end. Okay, so I'm just going to return result, and I am going to do the left shift. How many times? N minus 1 times. Okay, I'm just going to do the left shift, and then I am just going to run this code and see. Just hardly 10 lines of code, right? All the test cases has been accepted, and now let's submit it. So see, our solution is accepted, right? And the time complexity is going to be of n, and just space complexity, you can say that we are taking the constant values, right? So space complexity is of 1, and time complexity is of n. Okay, so see, actually this pattern is a little bit hard to recognize, right? But many times whenever there are huge test cases, okay, then we have to think about this, how we can find the result in of and time complexity. Okay, so I hope that you guys are able to understand all the approaches that we have discussed today. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and meet you guys in the next video. Thank you. Bye bye.